I would like to welcome everybody at today's first keynote session. I would like to warmly welcome our distinguished guest, Professor Gabriella Pasi. We are very happy that you are here with us today. And let me briefly describe the scientific biography of our distinguished guest. Professor Pasi is a professor of the University of Milano Bicocca. She leads the Information and Knowledge Representation, Retrieval and Reasoning Lab, as well as she's the head of Department of Informatics, Systems and Communication. She's a widely known expert in AI, especially interested in information retrieval and natural language processing, knowledge representation and reasoning, user modeling, and social media mining. She has outstanding scientific record, including more than 250 papers. She was a program chair in many international conferences, associate editor in several international journals with high impact. At least, for example, ACM Computing Surveys. This is very high impact journal in computer science. She was honored with many prestigious awards. And finally, she has been a member of the panel of experts for computer science of European Research Council. Professor Pasi, please come here.
Thank you very much.
And of course, the audience is yours.
Thank you. So thank you very much. I feel very honored to be here. I would like to thank students and also my colleagues for this invitation. I had the opportunity to tell to some of you that I find really extraordinary the effort that students are doing for organizing such a great event. Machine learning is nowadays very important, we know, and organizing an event in which you can gather people working in different fields to discuss these issues is very important. So let me thank you again. And thank you for the beautiful presentation. I don't feel this way, but anyway, it's very nice. So today I will bring you in a quick journey through the world of languages, okay? And in particular, I will talk about personalization. Personalization, especially in a task, which is information retrieval, but as you will see in my lecture, the second part will be more general. So I will talk about language and personalization. Personalization in language is important. Each of us, even when using a given natural language, is doing a personal usage of the language. Imagine the vocabulary. We have distinct vocabularies related to the tasks that we are performing, technical one versus simpler vocabularies, okay? Then I will talk about search and personalization. As I told you, my main area of expertise as a task in NLP is information retrieval, but not only. In my lab, we are working on different tasks. And then I will talk about the definition of personal language, large language models, which is an important issue, I believe, okay? So I hope you will find this interesting. I will not go into deep level of details, but I want just to mention important research directions. You know, we are living in a period in which large language models are used a lot. They are very useful. They revolutionized the field of vision, of course, but also of language, because they allow to represent in a more semantic-wise way the content of texts. But of course, they have their limitations. You know for sure ChatGPT, which is a chatbot based on a large language model. They have big potentialities, but they have also limits. Both with respect to their reasoning capabilities, they have not been defined to have reasoning capability, although they recently expose some of these characteristics. And they are energy consuming because they need a lot of resources. I am a quite enthusiastic person. I am a passionate researcher. Despite the fact that I have to manage administrative duties, I still love to do research. We are living a difficult period because people living in academia do not have the resources that people working in companies do have, both from a computational point of view and also from data sets point of view. But this makes our research challenging because we have to think ways of optimizing the consumption of resources. And so the second part of my talk will be focusing on how can we use such large models with less parameters for example, fine-tuning to specific tasks. Okay, so I don't want to spend much time because I will check myself in order not to go to overtime. So let's go. Shortly, I have a research lab in which I have several PhD students and also postdocs and a couple of associate professors. I don't spend time to describe what we are working on because my colleague introduced so well what we are doing. Generally, we are working around NLP, in particular for tasks such as information retrieval and chatbot and machine translation as well. I have one of my colleagues working on this. And we are involved in several projects. By the way, there is one of these projects, which is a doctoral network of Marie Curie, for which I am collaborating with one of your professor, Wojciech Kozlowski. We did know. So I have already a collaboration here in your university. So let's go on. That's interesting. Language is one of the means that human beings use for communicating. No? Is maybe the most important one, although it's not only based on language communication, as you know. So, in communication, we are sharing potential information. Why I am making use of the word potential? Because it's important to be able to access to genuine information in order to be informed. And this is not always the case, you know. In the social media, there are a lot of user-generated content. Nowadays, we have content generated by artificial intelligence, as you know very well. But there is also another aspect. Accessibility is related to readability, to understandability. If I explain what a search engine structure is to a child, I must make use of a specific vocabulary. I cannot make use of a technical vocabulary. So accessibility is an important problem in order to make use of true, genuine information. For example, this is an example with search engines. If a user is asking for cybersecurity, depending on the cognitive level and the expertise of the user, different documents will be judged relevant. This aspect is related to what we are talking about today, which is personalization, contextualization. So the idea of context is pervasive in human activities, you know. And I will outline this concept several times. Large language models, yes, they can take into account in context via prompting, but there is a more general notion of context, which is related to the task at hand, to specific topics, topical domains, and we will see how can we cope with this. So personalization is an important aspect. Here are some examples of personal usage of language, professional, biased by sentiment, and so on. Language can be personalized, related to single users, but also to groups of users. Let's think about a department, for example, the Department of Computer Science that I am leading, happily for still a few months, because after that I will be free. I will have more time to do research. So the lexicon is depending strongly on the context. So the word context is very important in languages. Ambiguities are the killer of NLP applications. So it's very important to try to model this aspect. So language of personalization, I've already been talking about this till now. And so how can we personalize language in the various tasks that cope with the management of language, among which information retrieval. Search engines make a very simple use, lexical based of language, at least in query. We formulate queries through a few words of a lexicon, although the internal representations may be more complex. Thank you, it's much better. So I can move, I prefer to move, and so I can turn out because here I cannot see. Thanks a lot. And let's see. Possible applications. We are actually working on some of these applications, okay? For example, identification of individuals at risks on social media. We are working on with a group of psychiatric of our university, because we have also Department of Medicine, about the signals of depression, and believe me, the usage of language for people at risk is peculiar. So observing the usage of language in this context is important. Prevention of social phenomena, filtering of unsuitable content for minor. Again, assessment of the veracity of contents, okay, information. Possible information and disinformation. In my lab, we are working on automatic detection of misinformation. Service for professional categories and job placement. Okay, but now I am going through the task of information retrieval, because at least the first part of my talk would be related to this example, okay, to this specific task in NLP. All of you know what a search engine is. We are using search engines every day, okay? I do not ask you which is the search engine that you use, because the answer is quite common, although some people are using also Bing, but they are very few. So I ask you, I cannot resist. How many of you are using something else, Google? Wow, very good. Very good, that's surprising. In a very positive way, I'm very happy. You know that recently Bing, for example, is combining the usage of large language chatbots, because large language models were introduced, by the way, first by Google, okay, to inject them into the search engine. So that's good. Basically, information retrieval is a decision-making process. Where the user, in principle, is central. The system has to propose the user those items which are going to satisfy the user's information needs, okay? In order to do this, the user should be central into the retrieval process, right? And in general, information retrieval is an interactive activity, interactive and iterative. How many of you are going to pose more questions in a query session? I mean, you start with a specific task, need, and then you are going to reformulate your queries. How many of you do this? Okay, it depends, of course, on the task. Which is the point here, that the first generation of search engines did not consider the user context at all. When we are talking about search engines, we are talking about different kinds of context, which may be the geographic context. Okay, I have my smartphone, I want to find a nice restaurant in Poznan, and so the dimension of the geographical location is taken into account by the search engine. Nowadays, search engines are taking into account a lot of factors of signals of relevance, included signals from users. So actually, search engines do cope with personalization at a certain extent. Personalize the search is organized in such a way, a user submits a query, the search engine is working to process this query. There is also a user model, which is representing the user preferences and interests, and so the input of the search engine is constituted not only by the query, but also by the user model. The user model can be formalized in various ways, based on different mathematical frameworks, okay? Then once the ranked list takes into account the user model and the query at the same time. So when we model a user, we have to cope with different kinds of problems. So first of all, we have to gather information which is related to the user interests. Basically, we make a distinction between implicit gathering and explicit gathering. This means that implicit gathering is I observe the user in her interactions with the various applications. Explicit, the user is asked to provide the relevant documents, which is difficult, it's not the best way to do this. Or again, we consider user-related documents. What are user-related documents? Documents authored by the user or posts that the user has produced on a social media and so on. Then the user-related information can be represented in order to give an idea of what are the user interests in the long time user interests, or in the short time. These are all issues that we have to cope with when we talk about user personalization. Exploitation of the user-related information. In search engine, basically we have two approaches in order to inject the personal view of a user in the retrieval process. The first one is personalized query expansion. I will show you a couple of slides explaining this, which is quite intuitive. But the most used is personalized result re-ranking. A posteriori, when the search engine has produced a ranked list, we make use of the user model in order to provide a re-ranking. So basically, in the pre-processing approach query expansion, the user is formulating a query. The query is automatically managed by the system in order to add or to modify keywords to capture the user interests. At this point, the modified query is submitted to the regular search engines. So, for example, 70s jazz, if I like Japanese music, the word Japan will be injected. This is a very, very simple example, of course. Then, the second approach, which is the most used, is result re-ranking, which is quite interesting. What is the ideas behind this? Is that the search engine is working, we obtain a ranked list of results, which are not shown to the user in this case. Then, by means of the user model, I can reorganize my ranking in such a way the user is looking in the top ranked position, those documents that are closer to the interests of the user. Which are the pros and cons of personalization? So this is an idea, okay? So the first stage retriever means the regular search engine. I submit a query such as jazz music. So the top ranked list is the one produced by my systems. If I do know that the user interests include Black Sabbath piano, I will revise my ranking, okay? What are the problems with the personalization? The problems with personalization are, first, that not all queries should be personalized, okay? If I want to submit a factual query, which is the birth date of someone or on which date a given event has been, standing, so I do not need to personalize. And this is one very, very important issue. How can I decide when personalize or not personalizing? So, I will present now some recent contributions of my research lab towards different problems. So first of all, how to represent a user model to leverage multiple representations of the user's interests, okay? So this first contribution is related to the definition of the user model, okay? The second contribution that I would like to shortly introduce is how to exploit the user interests related to the current query, which is related to what I was telling you before. If I ask for a given query, the query may be related to my personal interests or not. If it is related to my personal interests, is it related to all my interests? Absolutely not. Because in my user model, I can have representation of my free time interests, I like music, for example, or to my technical job-related interests. So it's very important and interesting at query time defining a mechanism which is looking at the query and based on the query make a selection of the user interests that may be important to personalize that particular query. So this contribution is an interesting contribution in my opinion because we have modified the attention mechanism in order to leverage the specific user interests to the query at hand, okay? The last part is related to a topic that I like very much. How can we personalize the large language model? And in my research group, we are working towards, let's say, parameter-efficient methods. You know that when we are talking about large language models, we are talking about millions of parameters. And when we train a language model on a given data set, and then we want to adapt that language model on a specific task or on a specific domain, we may work with fine-tuning. But if we fine-tune a model separately for each task, this is very heavy in terms of computational resources. So we take care about applying selective defining, let's say inventing, and applying selective methods that allow to train in fine-tuning less parameters, okay? I will talk shortly about this, because what I like to do today is to give you interesting and possibly challenging research perspective for the future, okay? So I go on, I look at the watch. So I will be very quick, this is quite intuitive. Multiple representation. By the way, this is related to the project that we are undertaking, the doctoral network on, we are working with Professor Kozlowski, is learning from multiple representation, which is a very challenging topic. Can I learn what? Something to perform well, some tasks? Not for just one representation of a given reality, but for multiple representation. So in the context of natural language processing and in tasks such as search and dialogue systems, for example, how can I interpret the notion of multiple representation? What I am talking about now is just one very simple instance. Multiple representations means, okay, I look at the user, I look at the information items on which I am working, and so I can capture different perspectives of those objects in order to describe different properties and point of view, okay? Instead of representing a user model just through words, okay, I represent a user model by means of either multimodal information or by means of different kinds of information. This is a possible interpretation of a multiple representation. Another possible interpretation is that the text can be represented as a bag of words, as a dense, via dense representation, graph-based representations. I can gather all of these and try to learn from different and multiple representations. But I have no time to go into the deep level of details. So by this first work that I have done with the former PhD students, we have been considering product search, which is a particular search task in which the aim is to find products that can be useful to a given user, okay? So in this case, the multiple representation user model that we have defined takes into account different kinds of information of which we had the availability, because an important aspect is to have available data and numerous data in order to cope with machine learning, deep learning based approaches. So we have been in particularly using texts which have been authored by a user, so the reviews that a specific user has written about products that she bought in a given time span, okay? Then we have been taking into account user items interactions. So basically we have constructed a graph, the nodes of which are items and users, and we have observed the interactions between users and items, just to project in a dense space the closer users who are users who had similar buying behavior, and also the close items. Then we have also considered the categorical information of related to the items themselves. We have applied a result re-ranking, as I introduced you before, in order to inject personalization. And we have performed evaluations, in applied fields of computer science, of artificial intelligence. You have to, not to prove, but to show that what you are proposing is effective. This is a very important topic. I could open a parenthesis related to this, because a lot of people publish papers showing that their approach is outperforming, sometimes at a small extent, previous approaches. Then you are willing to open the box, and often you realize that you are not able to reproduce fully the experiments because the code they give is not complete, because data sets are not available. The problem is of open science. I talk to you who are young students with a brilliant future in front of you. Open science is important. Share code, share data sets, allow to other scientists to reproduce what you are studying is very important, okay? Of course, we are going more and more towards this direction. It's not so simple. Anyway, I tell you that you should take this into account in your future activities. So, I go quick here because what is important that the approach that we have defined is extendable, in the sense that if we find more representation in this context, we can easily add them. So the idea is very simple, okay? We are going to separately make representations, dense representation of the various aspects that I mentioned before. So basically we are taking reviews and we are applying a doc-to-vec approach in which the text is embedded into a vector. And we do this for each review the user has written. Then we take we do the same with the items. So we take the items and the reviews that have been written by distant users related to this item, and we do apply the same representation, okay? In order to be able to compare the two, we take the average of the embedded representation of both the user and the items, and then we apply a cosine similarity in order to see how close a given item is to a given user. Highest closeness means that the user may be most highly interested in a given product, okay? Then we consider the user item interaction graph, and we are going to produce an embedded representation both of the user node related to the user and of the items, and we do the same. We compare this representation, and then also category-based item representation. What is category-based representation? In product search, often you have taxonomies in which products are associated with the categories, and so we make an analysis of the categories of the product that the user formerly bought. And we do the same with items, and we use the similarity of product categories with the categories in which the user is interested as another signal of closeness and possible interests of a user into a product. Okay. Then once we do this, we aggregate the various scores that we have independently obtained in order to combine them with the first ranked retriever. We use lexical matching retriever in this to do experiments, basically, but not only. And then we combine this first ranked retrieval score with the scores that we have computed this way. So we have tested again classical retrieval models and other personalized models at the state of the art. And then we have seen that we achieved very good improvements. NDCG is a measure which is going to compare ranked list of documents with respect to an ideal list. Okay, I do not have time to comment, but I just give you an idea. It's quite obvious, no? The more I can, the more precisely, and the more I can describe the model of a user, no? the preference of a user, the better is the results that I obtain, okay? So let's go on. I am very proud of this work because I find this is very interesting, the generalizing attention mechanism. This second work is related to the selection of a subpart of the user model, which is going to represent the interests which are useful to personalize a specific query. So the idea is to define the user model at query time. So I told you before that not all information related to a user representing the user interest is useful to personalize a query. So, and more than this, personalization should not be applied to any query that the user is submitting to the system. So, the objective is to define an embedded user model. Important, I did not mention this explicitly. Also, the previous work is finalized to define an embedded user model, okay? To define an embedded user model at query time, which emphasizes the user's interest aligned with the current query. The proposed solution is that we want to use, to weight the user-related information. What do I mean by weighting the user-related information? Imagine that the source of information of the user interests is constituted by documents, okay, by texts written by my author, okay? Some of these will be related, for example, to job, other to personal interests. The idea is which one I should take into account to personalize a specific query. Okay, so focusing on those texts that better represent the user interests related to the information needs expressed in the specific query. So we thought the following thing. Okay, we can make use of the attention mechanism, but this was not novel because in the literature other people applied the attention mechanism. How many of you do know what the attention mechanism is? Okay, almost all of you. That's good. So the attention mechanism, as you know, is a way of selectively focusing on a given aspect when you have an overall scene. No? In this very nice example, I like this example because this cat is very similar to my cat. And you are going to look at an image and you are focusing your attention on what is interesting to you. To me, it's extremely interesting, the cat, because we have an affective relationship, okay? So each user, each person is going to focus based on his interests. The same applies for text, okay? So what is the attention mechanism? It's a mechanism that is finalized to produce a mechanism like the human selective focus. The idea is the following. In the attention, the aim of the attention is to compute, is to build what is called a context vector. We are talking about context now. We have a composite scene, okay? We have a text with various aspects, and we want to focus on specific aspects, which are contextual, of course. So the idea is to compute a context vector by weighting the available contextual information with respect to given input. I have an input, which is the information that I should leverage, on which I must be attentive to produce a desired outcome. In our application to search, the context vector is the user model. I do want to construct at query time a proper user model by selecting only part of the user-related information. The available contextual information is constituted by the user-related documents, by the sources of information about the user interests. With respect to a given query, the input is the query. Is that clear? So I have a query, and so I want to select the user's document. So attention mechanism, as I told you before, has been applied to personalization. So we have not invented the application of the attention mechanism to define user models. But what we have done is to analyze the behavior, the performance of a mere application of the attention mechanism to this purpose, to model contextual user knowledge. And we discovered that the pure application of the traditional attention mechanism is not good. I will show you in a few slides why. And we proposed a possible solution. So in the attention mechanism, we have three basic steps. Scoring, which is the alignment. Basically, for each, I apply this to our task of retrieval, okay? So for each user-related document, we align the document with the query. Basically, we do a matching, document query, to see how much a given document is related to the query. Low matching score, low correlation, okay? Then we do this for all user-related documents. Then in the attention mechanism, there is a normalization step, okay? The normalization of the matching scores produces the attention weights. So the attention weights are normalized scores, which are based on the alignment scores. This step in normal attention is accomplished through the use of the softmax function. The softmax is a generalization of the argmax, which is continuous and differentiable, which is a property important for neural networks. This has been defined in the context of classification. So you may understand why the softmax is used, generalization of the argmax. We have to select a given class, okay? But in the case of our application, this is not exactly the case. Then there is the aggregation. So at this point, when I have the attention weight, I just combine, okay, by means of the attention weight, the contextual information, okay? So I do a weighted aggregation. So softmax normalization produces a probability distribution. So in this very simple example, we have produced 4 alignment scores. The negative values means that there is a negative correlation, not good, okay? If I apply the softmax, in this case, I obtain a probability distribution, yes, I go quick, which is not really desirable because values are all positive. I cannot zero any of these components, and I can obtain noisy user representations. You see that the representation is skewed about one weight. We have a very high weight and other weights that are very slow. So what we did, we proposed a modification by means of a filtering step, which is a rectifier linear unit. First of all, we apply a shifting with a threshold in order to mark more the negative contribution of the weights and to make certain documents not useful at all, okay? And then we apply a normalization. We replace the softmax with a kind of normal, a simple normalization, which is based on the sum of all weights, okay? So what we obtain is something like this. In this case, with these alignment scores, our mechanism produces the attention weights that you see on the left-hand side, and the normal attention is producing that mechanism. What is the advantage of what we obtain? That we can zero the contribution of some of the documents. So this means, please forget those interests when personalizing this specific query, which is good, because we can decide not to personalize certain queries by means of certain documents. Okay, I am a bit late, then we apply this to re-ranking, and the results are quite good. We have obtained an improvement of 15%. I do not report all figures. Now, that's very interesting. I try to be very quick on this. Personalized large language models through fine-tuning techniques. So, okay, previous works have been based basically on those approaches that you can read on this slide. Prompting techniques, you know what is prompting, no? Prompting is able to model what we call in context, okay? So you have a large language model which is trained on a given data set, via prompting, you can adapt the context at hand at a given moment, okay? And you can model a contextual, the idea of context, which is local, which is not general, okay? Then we have, okay, vanilla personalized prompts means that on a pre-trained language model you can define personalized prompts related to a given user. But the idea is to use prompting in this case. Then recently people have suggested retrieval augmented generation. What do this means? Okay, if I want to prompt will the rich information which is related to a given user, I will obtain a lot of potential information. I am not focused, and this is not efficient. And this does not produce results in an efficient way, and it's even difficult because you have to pass concise information. So the idea of retrieval augmented generation is that, okay, I pre-filter those user-related information which is matching more the user interests. So I do a retrieval step in which from the user-related documents I take those that better represent a given context and I make use of this. It's working, yes, it is working, but also this approach has some limitations that I am not able to list all of them. But the issues with prompting technique in general is that has been shown from an experimental point of view, is that small changes in punctuation, for example, can drop performance by 80%, which is very, very big. And another issue is how to evaluate the personalized text and how much the model is personalizing the output. Another method is, other methods that are at the more recent state of the art, is that how to apply fine-tuning to personalize large language models, which is good. If I want to define, you know, if you train a large language model, fine-tuning is good to adapt this large language model to make a transfer, okay, to represent a given task or a given topical domain. In the case of user models, fine-tuning, ideally, means that I take a pre-trained language model and I do obtain a personal language model by means of fine-tuning for each user separately, which is extremely heavy. You may imagine, no? From a computational point of view, in giving the input to the models. So usually this is not convenient. No? This would perform well, but it's very resource consuming. So recently, parameter efficient fine-tuning techniques have been proposed. And we are in this context, we have proposed novel methods. And recently we are using this mixture of expert approach to machine learning, in which the idea is that the model is a kind of composed of several specialized models, okay? There is a gating mechanism when an input is provided. The gating mechanism is addressing our input to the right specialized model. What do experts represent? For example, topical domains. I may have topical domains related to various categories, arts, sciences, and so on. Or various tasks. Okay, the application of mixture of experts has been mainly applied up to now to, yes, I will just a few slides, has been applied to define models that adapt to different tasks. And here the experts are the sub-models that have been specialized to those tasks. And this is a very promising direction. So, adapters for at the state of the art, okay, parameter efficient fine-tunings is obtained, for example, by adapters. I believe you know what adapters are. In this case, you are adding a layer into your transformer deep architecture, okay? And this layer there are basically two approaches. The HASB adapter is going to introduce in a new layer a few parameters which are specialized with respect to a given task. So the idea is that when you are adapting a given model to a specific task or to a specific domain, you have just to retrain much less parameters than the whole picture, okay? In the LoRa, lower rank is an acronym of lower rank, you do behave in another way. You just take the same number of parameters of the whole model, but what you do is right-hand side to decompose your big metrics into two lower dimensional metrics, and this allows to more efficiently train with a reduced dimension of our vectors. What we did in this context? We have applied a technique which is introducing two parallel down projection, okay, for the adapter level in order to increase efficiency. The proposed approach is called Adacron, so this contribution is specifically defined in order to improve the usage of resources, in order to fine-tune. And I just wanted to give you an example. If the input vector is 48, okay, if D is the dimension of the input vector and 48 is the intermediate dimension of the adapter, with our approach based on this Adacron, based on this, Kronecker products, which is usually applied to matrices, we applied it to vectors, okay? We save 1/3 of the length. We reduce computations to just 1/3, which is a big advantage. Okay, I am going toward the end. Okay, of course we have evaluated this against other kinds of adapter, the one that I mentioned before, and what you obtain on different language inference tasks, okay, and we obtain very promising results. This is the very last slide, or yes, I believe this is the last slide. I have already mentioned that we are working with a mixture of experts, and we have been applying mixture of experts to the question answering tasks in natural language processing. So we have specialized our experts, our sub-models, on different topical domains. And this is really, really promising because we obtain very nice results. And this mixture of expert approach was not applied at IR, at search yet. And it's promising because we obtain a way to take into account context and to work with a sub-model which is specialized. How the sub-model is activated? By means of a gating function, okay? So in the future we want to combine the two aspects, Adacron, which is based on the Kronecker products, and mixture of experts, in order to obtain interpretable, personalized large language model, okay? So the last part I just mentioned that one of the main issues when we are talking about personalization is how can I do evaluations? Because evaluations usually are not taking explicitly the user into account. The user must be taken into account instead. Also in information retrieval, we evaluate based on predefined data sets in which relevance judgments have been done from scratch from assessors. But the same query can be evaluated relevant in a different way from different users. So we do need to define experiments in which personalized approaches are evaluated by taking into account the users. Okay, challenging personalization is important by preserving privacy of users. Okay, the approaches on which we are working are also considering this aspect. Learning from multiple representation in NLP-related tasks is an important aspect. And the evaluation of personalization is an important issue. I just finished telling you one thing, quick thing. You are working on machine learning, you are experts of machine learning, I am sure you are very good students. One of the main problems we have nowadays, and we realize this because we develop applications, is the resources that are necessary. So there is a huge consumption of resources, which is translated into a severe consumption of energy, water, and so on. So we have to think our research towards a better, impactful research on the environment. So energy saving computing is important, and in machine learning especially, this is an important issue and challenge. I hope to have transferred at least some curiosity and some information. Thank you very much for your attention again. Thank you. I was a bit long. I was a little bit long.
Thank you. Thank you very much for a very nice presentation. And we have some time for questions. Do you have any questions? Yes, please.
Thank you.
Thank you for such great presentation.
Thank you.
I have a question concerning the denoising attention mechanism. And to be exact, the step right after scoring, so is this shifting those scoring values?
Yes.
How do you choose the value
The threshold.
Yes, exactly.
Yeah.
Is it a hyperparameter or you just chose it and fixed it? And if you fixed
No,
it...
it's a parameter that you can choose based also on the data set, based on... that's an issue, of course, but which is important when you have parameters to be set, that's important. Yes, we fix based on experiments and based on the data set, because the idea is that you want to emphasize those aspects which are not related to the query, and so you want to make neutral those aspects and eliminate so that your model can tell you have not to personalize on this topic. You are right.
Okay, thank you. So is it possible to extend this parameter to be, for example, learnable from the dataset, or for example, from something?
Yeah. I believe so. This paper has been accepted at the North American ACL conference and will be published. If you are interested, we can share ideas. And I wanted to tell you, if you wanted to do an Erasmus period in Milano, you will be more than welcome, and if you are interested related to NLP, of course,
okay.
Because you are students of machine learning, theoretical machine learning, but maybe also applied machine learning.
Thank you very much for the answer.
Thank you, thank you.
Are there any questions? Yes, please.
The mixture of experts seems to be similar to the Google switch architecture. Can you comment on that?
Yes, the issue with the mixture of experts for our experiments and what we want to do is that what we aim to try experimentally, we can really work on the definition of specific models which may be tuned on given aspects which can be related both to tasks and to user-related documents, because we are working with the texts, and so
that's clear. But I was specifically asking about Google Switch architecture, which has been around for like 2 years, and it basically is a collection of experts.
Yes, that's
and
true.
the gating and switch. So I'm wondering how this differs.
Improves. We did not make any comparative evaluations, but you are right. We should do this. Because they are alternative methods in order to model expertise and injecting knowledge into. But we did not make any comparative evaluation at the moment, because we just started to work in this direction, and we have applied it to question answering and compared the two state-of-the-art approaches in question answering, and as I reported, they are promising, but we are going on this direction, so for sure. that has been done from a comparative evaluation point of view.
Thank you for the talk. Have you tested this personalization fine-tuning and compared before fine-tuning and after fine-tuning? Because I see a problem that for many users we may not have a lot of data and maybe it gets too biased to small context. Have you tested it?
Yeah, this is exactly the issue of evaluation that I had no time to talk about more. Sure. You may have a cold start problem with users in the sense that if you have a few documents, this is not particularly convenient. We have been doing comparative evaluations with no personalization and personalization, yes, sure. And also with different first stage retrievers, lexical versus neural.